reactions we have discussed so far. We'll start from there and we'll see where we go. So first one which you're talking about is LiLH4, right?
Yes, sir.
Okay, LiLH4, we have some doubts about how LiLH4 is actually going to be working. Is that correct?
Yes, sir. Yeah.
Okay. When we say actually working, what do you mean? What is the exact doubt here?
He gave us the mechanism, and then like that is fine, but like
see, LiLH4 here is going to be something which is going to be actually a mixture of lithium hydride and ALH3. Okay.
Yeah.
So what happens over here is the LiH here can more easily break down into Li plus and H minus when the H minus is in the presence of something which will stabilize it. H minus is not normally stable. Okay, so H minus is not that stable. That is the reason why it doesn't break that easily. Here though, there is something like ALH3 which is available over here, which is going to be stabilizing the H minus.
Electron diffusion.
Okay, so this mixture together is actually something which you can think of as H minus in ALH3. Now, H minus in ALH3. ALH3 here is going to be having its central figure here being the aluminium, which is going to be having a coordinate covalent bond right now with the, hydrogen in the form of H minus ion. So the ALH3 here is going to be having a coordinate covalent bond with the hydrogen, which is the part of the H minus ion here, with the H minus ion here. So what happens in this case here is the attractive force between the aluminium 3 plus ion and the H minus is what is going to be determining how strong this LiAlH4 is as a reducing agent. Because when it is behaving as a reducing agent here, so if I have to consider this as a reducing agent, the basic idea here is this fellow has to release H minus. And that H minus should go attack as a nucleophile. That is basically the game when you're going to be having this LiLH4 behaving as a reducing agent. Now, when you mentioned that you have some confusion regarding LiLH4 behaving as a reducing agent, I'm assuming that had some connection with the NABH4 also, or is it not having any connection?
I mean, it was like specific to this this reaction.
Okay, give me the reaction now specifically.
Sir, like it was just like he gave the mechanism of how ester is reduced by ALH4.
Ester,
yes. And then before that he also gave how like once the ester reduces, it reduces to this aldehyde, right? So the aldehyde again it reduces to alcohol. So he asked us for one molecule of ester, how many molecules of LiLH4 are needed? He said 2 are needed, but then how is it?
Think. So let's say I am having an ester. Let's take a simple methyl ester. Okay. If I want to perform a reduction of this with H minus. Okay. What happens over here is the first H minus
carbon
will come and attack this.
Yeah.
As expected. It will perform a nucleophilic addition, resulting in this guy being formed. Yes?
Yeah.
Now, this step is reversible. Yes or no? It's a nucleophilic addition step. All nucleophilic additions reactions are reversible in nature. All acid-base reactions are reversible. All nucleophilic addition reactions are reversible. Okay, so this is a reversible step. In the next step here, what is going to be happening is this O minus here has got 3 lone pairs now. Correct?
Yeah.
One of them will shift inward here, and these 2 electrons will be taken over by the oxygen here, which already has 2. And we end up having this oxygen basically leaving outside.
Okay.
Okay. So now, in this next step, what is going to be obtained as a product here? You'll be having R,
This aldehyde.
yes, C double bond O H. And we
Yeah.
are going to be having this oxygen here, having the two lone pairs left over. This is this oxygen, number 1.
Yeah.
Okay. Where is oxygen number 2 now? On the other hand, oxygen number 2 has gotten out
Methanol.
in the form of CH3O minus, where it has got 3 lone pairs now for itself.
Okay. So is that O minus again attacked by the...
Stop. Let us now look at this particular reaction again now a little bit more closely before we move further. This reaction here, look at the backward direction of the reaction. What is the forward direction here? That is, if I look at it from this direction point of view, what is the reaction? Huh? Elimination. It is basically a leaving group is leaving.
Yeah.
Correct? Huh? So nucleophilic elimination is a way to look at this.
Okay.
Correct?
Yeah.
Now look at this direction now.
Nucleophilic addition. It will be.
Now think about what happened over here. Nucleophilic addition is reversible.
Yeah.
Basically, this step which we are looking at currently is also reversible then.
Yeah.
Correct? So does that answer your question before it even starts? Yes or no? Can the CH3O minus go attack again? Yes, of course. That is reversible part there.
Yeah.
Fair or not?
Yes, sir. Yeah.
Now, in this process here, we have consumed how much of this?
1 equivalent. Yeah.
Okay. Yeah?
H minus from LA.
For what we have currently. We have an R C double bond OH. You're saying something just now.
That H minus is from LiAlH4 minus.
Yes, of course. Yes, of course.
Okay.
This is absolutely from LiLH4. Now, we have got the aldehyde in stock right now. This aldehyde can now react with another H minus from LiLH4, of course. Okay. And this particular H minus will now again go and perform yet another nucleophilic addition reaction.
Same reaction. I mean, yeah. But
Not,
no leave this time.
Well, yeah, from principle it is the same.
Yeah.
But different products are going to be obtained. In which case we'll be having RC. Now we will have 2 hydrogens attached and I will have an O minus. The O minus will of course have 3 lone pairs of oxygen, 3 lone pairs of electrons on the oxygen. Because one of the pairs of electrons now ends up being taken over and becomes a lone pair here.
Yeah.
So this is basically what is going to be happening in this case here, which of course is then going to be accepting a H plus from water when you end up performing hydrolysis, either from H2O or from H3O plus, whichever way you look at it, you'll end up having this fellow basically ends up accepting and will end up becoming RCH2OH. Of course, what is going to be happening? This step is an acid-base neutralization. So what does that mean?
Reversible.
Reversible.
Sir, our teacher kind of just a second.
Now have a look here. How many moles is going to be consumed here? In this step here, 1 mole is consumed.
So 1 plus 1, 2, yeah. But then he gave us like, I'll just send it.
Wait a second, let's finish off, then you compare. So basically, if we are going to be having ester,
1
RC double bond O R dash. If I hit it with LiAlH4, all right, with 1 equivalent, I will end up having the product being RC double bond OH plus R dash O minus. If I hit this guy with 1 more equivalent now,
alcohol.
then I'll be getting RCH2OH.
Okay. Yeah.
You understand the process here?
Yes, sir. Yeah.
Now ask your question based on what your teacher has done in school.
Just a second. It's not exactly the same, but I sent it, sir.
Yeah. No, no, no. This is. Are you sure your teacher gave you this?
That's what I copied, sir. Yeah. Like the signs might be wrong, the plus minus.
Yeah, that is the problem. That's why I'm asking exactly kya hua hai.
I may have copied it wrong, but I was also like,
See,
no,
see,
I'm
see.
pretty
Stop,
sure.
stop, 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 stop. That is not the point over here. Doesn't matter. Let me just quickly explain to you what is the correct, exactly what is given there. Now, in this step here, you see this step
Hmm.
marked here?
Yeah.
So in this step over here,
Instead of OH,
yeah, basically, what is this guy?
nucleophile.
Oh, let's call this as species 2. Let's call it as 2. Let's observe it a little bit more closely in the next page. So we're going to be having R CH2O minus, correct?
Yes, sir. Yeah.
It has now currently formed by the attack of H minus on the aldehyde, correct? When the
Hmm.
H minus attacked the aldehyde location, we had RCH2O minus formed at that instant.
Yeah.
Right. So when that formed over here, now you have this O minus produced right now. What else is present in the medium?
The
What
AL,
simultaneously? Your
AL.
LiAlH4
Yeah. Yes.
originally broke up to become Li plus AlH4 minus.
Hmm.
Correct?
Yes, sir.
Each time the AlH4 ended up reacting, it breaks into a H minus and
AL.
H3.
Oh,
So on and
okay.
so forth. Because the ion which is present is aluminium plus 3.
Hmm.
Okay?
Yeah.
Aluminium plus 3 is the ion which is present. It can form a particular coordinate covalent bond with either the H minus present here or with the O minus.
O minus. Hmm.
Either of the two. It doesn't give a shit in the beginning. In fact, it prefers the O minus more than the H minus. Why? Because aluminium is more metallic in nature, meaning it prefers something which can hold
Yeah.
the negative charge in a better manner.
More electronegative that. Yeah.
Exactly. So oxygen is basically a much more preferred partner for the aluminium 3 plus ion.
Yeah.
So what is going to be happening here is you're going to be having the aluminium 3 plus originally was something which was present in the form of AlH4 minus 1. It is trading the H minus ion, which is
For
not
no
that good
minus.
of a partner, for a
Hmm.
better partner. What is going to be the final state in this particular case here? It is going to be present as Al O CH2 R
Hmm.
entire thing minus
It's
1. There are
oh,
4 of these.
okay.
But where is the negative charge? The negative charge is on the goddamn oxygen. All right. The
Mean.
negative charge is on the oxygen here, not anywhere else. There are 4 of these here.
Hmm.
The negative charge is going to be on the oxygen here individually. The aluminium is going to be with a goddamn plus 3. This is a
Yeah.
coordination complex.
Hmm.
Okay. Now this fellow is the one which we are undergoing hydrolysis with.
Yeah. Okay.
You
Then
understand the idea here?
yes,
When
sir.
we do that, we will end up having RCH2OH uptake.
4 moles.
For every 1 full mole of this compound, you get 4 moles of this guy.
Yeah. Then in that case, won't we need 1/4 moles of LH4?
Equivalents, not moles. Moles is different. You're confusing equivalents and moles. Look at the terminology I've used here. Very carefully, I put one equivalent in every spot.
Uh-huh.
One equivalent now, one amount of H minus. So N factor for LiLH4 is 4. So yes.
4. Yeah.
So LiLH4 N factor is 4.
Yes.
So if
Yeah.
I'm going to be having, say, ester plus LiLH4. Technically speaking, when you're writing the equation, you have to put it as one equivalent. All right. So 2 equivalents now, we will end up having product obtained as RCH2OH plus R dash OH.
Okay.
And how many moles we'll be having balancing wise? 1 mole of ester requires 2 equivalents of H minus. So 1 mole of ester needs 2 equivalents of H minus. 1 mole of LiAlH4 provides how many equivalents of H minus? Can provide 4 equivalents of H minus.
Yeah.
Okay. So what will happen now? That means you'll end up having balancing wise 2, 2, 2. You understand the idea here?
Yes, sir. Yeah. Yeah.
Really?
Yes, sir.
Why do I not see shit on your face properly getting convincing?
I got it, sir. I got it.
Okay, what else next? Now, with what acid derivatives will this reaction happen?
What's that? I get it.
Ester ke saath you talked about a reaction now, correct?
Yeah.
So now my next question is, with which other acid derivatives can this happen? When you consider acid derivatives.
Oh, acid halide. Like that.
Good, yes. Acid derivatives are going to be your derivatives formed from acid. So ester.
Carboxylic acid.
Will that give?
Yes.
Carboxylic acid with what?
With LA, that's one.
What did you learn about that?
I don't think it gives reaction actually. Right?
Yes, it doesn't react.
Yeah, it doesn't. It's very less reactive. My bad. Yeah.
What is the reaction between these two?
It won't react. I mean, very less yield.
Stupid bugger.
Sorry, it will react, sir. It'll give alcohol.
No. It will react, yes, that is true. But not to give alcohol. What will be the reaction?
Acid-based reaction.
Nothing else will happen. No redox. Okay.
Okay.
Now, if we are going to be having the ester with LiLH4, in this case here, 1 mole reacts with 2 equivalents to give product as alcohol.
Yeah.
What other acid derivatives do similar reactions? Ester ke liye it works, yes. You mentioned one more. Acid
Acid
halide.
halide.
That is also true. So acid
Uh,
halide, let's see what will happen here.
huh.
Acid halide, what will happen? Let's take the acid halide.
One mole is enough, I guess.
So in this case here, how many equivalents?
No. Two equivalents. Here also.
Two equivalents here also.
Cl will leave.
So 1 mole is going to be requiring 2 equivalents here as well
Hmm.
to finally give you
Alcohol.
RCH2OH.
Hmm.
Right?
Yeah.
This is going to be the product obtained over here. So in this case also, it is going to be first acid halide. Then you get what? Aldehyde. Then you get alcohol.
Then alcohol, yes.
Fair?
Yes.
Now, how about some other acid derivative? How about an anhydride?
Anhydride.
Let's say I have an acid anhydride.
Yes, I think this will do. Two equivalents.
Think and then answer. Use your brain first.
So what's the exact question?
Can this be reduced by
LiLH4.
NiLH4 properly, completely? And if so, how many?
1 second. So to get like two different alcohols are formed, right? I mean, if let's say it does react, then two will form. So like, are you asking?
You think and tell what are possibilities. Do not try to give me an answer. Try to give me possibilities. Create the options.
Okay, then first like it's an SN2 reaction, so it'll attack wherever the R is
SN
smaller.
to what?
Yeah.
What is the mechanism we have been seeing till now? It is called nucleophilic addition followed by elimination. Look, I'll show you. In this year, when Esther was doing here, what is this two-step mechanism called? Look at the process. This is a nucleophilic addition. This is
Nucleation elimination.
nucleophilic elimination.
Additional elimination.
Okay. So this particular reaction here is actually called as nucleophilic addition elimination.
Oh, sorry, this is not SN2. My bad. No. Something else was SN2.
So this entire two-step process, this is the addition elimination reaction.
Okay.
All right. So all acid derivatives do this mechanism. Now,
Okay.
what
Yeah.
will be happening here?
Then in this case, it could either the H minus will either attack either of the carbons. So and then once it attacks this O, that ester group will leave. Like, and then you'll get an aldehyde, and then
That is mechanism.
yeah.
My question is, what is the final analysis?
Okay, then 1 second.
Arey. Okay, good. You're doing the right thing, putting pen to paper. It's nice to see that you're doing that. Yeah, but let me just quickly give you the analysis here anyway. The analysis is going to be, yes, you will have two possibilities. In one case, you'll have two equivalents consumed, and you can get one of the two products, RCH2OH,
Or R dash.
yes, or
Hmm.
R dash CH2OH, plus you'll be getting, of course, the other fellow. In the first case, R dash CO minus you'll be getting. In this case, RCO minus you'll be getting.
Hmm.
Or if we are somehow able to, how to put it, to extract from this also, because these two are also possibilities from which we might be able to extract the LiLH4, or from which we might be able to get the corresponding alcohols as well. So if I'm trying to get it from this also together, then if somehow or the other, if they are giving, say, some 4 equivalents type of shit, what will happen in that case? Yes,
each of them would require.
probably make up that you'll have both sides basically undergoing reduction completely.
Yeah.
How it will happen, it's not particularly clear. Why is there a problem with how it happens? Mainly
Too
because
many.
RCO minus, when you perform hydrolysis, it will end up becoming RCOH or R dash COH,
Which is slowly, which will
which
not be reactive.
only does acid-base reaction with LiLH4, which is basically the backward.
Sir, how did you say that LiLH4 will reduce this thing? Like, is there a solid way to tell?
Which one?
This you asked first of all whether it will reduce acid anhydride, and then you said if so, then
Can you explain which part you had a confusion on? My
no, sir.
usage of words?
You said you asked me whether first of all will LiLH4 react with reduce acid anhydride, and if so, how many equivalents? So how do we know exactly that it will do it? It will reduce.
We know for a fact this is going to be something where there are, what to say, locations which are having high delta plus.
Yeah, but even for RCOH also there is a place like
No,
that. Right?
RCOH, there is going to be H delta plus there.
C delta plus also there, right?
Highest delta plus is on hydrogen. That is why it is an acid-base reaction. Nah?
Oh, like that. Okay.
Think for a second. Now, why the hell is this guy who is interested in attacking a desperate center going and attacking a carbon? Because the carbon is the only center available here. When there is a hydrogen available with the delta plus, that becomes far more attractive.
Okay, 1 second. Got it. Yeah. So just 1 second. Okay. Just a second.
Next up,
1 minute, sir.
what other acid derivatives are you familiar with?
Sir, one more thing, like catalytic reduction of functional groups, like there also RCOH is very less reactive with H2 and nickel, right?
Yes.
Is there a similar reason for that? What's the reason for that?
No.
The
reasoning there is going to be slightly different. Hydrogen and nickel is something which is going to be preferring to attack a system which is closer to non-polar. The polarity in the carboxylic acid is very high. Which is
between
also,
O and H or what?
Yeah, we know the O and the H, yeah.
Okay.
So that takes precedence.
What about if we consider the C and double bond?
See, when you're going to be having the C and double bond, what is happening in that C and double bond there? It is having a resonance.
Yeah.
When it has a resonance, what is the actual location where the delta plus is focused in?
Hydrogen.
Correct.
Yeah.
Because of resonance, you'll end up having things. Basically, the hydrogen is going to be the sacrificial lamb at the end of the day, finally. There is no escape for that fellow there.
Yeah.
So think of it as this is a molecule which is heavy in one side, but the lightest side is also going to be extremely weird in its own way. It is also extremely heavy in terms of the charge density it is carrying. So it is, think of it like an axe, a catapult or an axe or whatever it is. something which has got like two different ends. One end is heavier, the other end is lighter. One end is bigger, the other end is smaller. Problem is the smaller end is also heavy in its own way. Except it is not heavy in terms of the mass, but
Hard
it is
to
heavy in
hold.
terms of the charge.
Like
You
hard to
understand the idea there?
Yeah.
So the entire molecule is going to be a wobbly molecule when you're throwing it at any particular system there. And which direction will it basically end up falling on predominantly around this region? Basically, this is going to be its most reactive spot. So any reaction which it comes across, it will try to move into that particular, that will be the one which is going to be focused on. If you are not having a hydrogen, then it is not an imbalanced spot there. It is not a tiny location which is having that much charge. It is spread out a little bit more. When it is spread out a little bit more, it is less problematic.
Yeah.
You understand the idea there?
Yes. Yes.
So in that case, this location is going to be more feasibly targetable. Because you want to basically target this location and not get the distraction happening over here.
Yeah.
But if the molecule is something which is like having a hydrogen here, then yeah, nothing can be done. Hydrogen is like a Victoria's Secret model, basically. I mean, maybe not the current ones. I don't know how it works now, but something like that. Whereas the other groups, if they are going to be present, they are like plus size models. They are enough. Now, anyway, coming back, actually, no, now that is a very wrong statement because now Victoria's Secret models are plus size models. Woke thing has basically gone very interesting. But that's not the concern now. Let's come back to this. So the idea here is you end up having, when the hydrogen is present, it will distract from everything else. As when there is no hydrogen, when there are other groups there, the focus is going to be on the carbonyl part of the group there still, which means the reduction happens more easily. Effective.
Okay, sir. Yeah. Sir, are there any other stuff LiLH4 does not react with? Like, basically, it doesn't react with anything which, I mean, it doesn't reduce anything which distracts it, basically, like has something else which
Yes.
has more delta.
If you do a direct acid base, it will not be reacting with it.
Okay. Like, for example, if you had okay, sir, does it reduce the double bond and triple bond?
No. LiLH4 works on polar systems only predominantly. If the double bond or triple bond was part of something which increased the polarity on that system, yes, it can probably do that. For instance, let's say I'm going to be having something like, I think I discussed this a couple of classes back, maybe. I don't remember now. If I have a system like, say, this, okay, and let's say I have a system like this.
I think, yeah, you did discuss like this.
Okay, if I have these two. Now, if I use LiAlH4, yeah, it will technically be capable of doing reduction on this and this under correct circumstances.
Yeah.
Okay. Now, in this case, LiLH4 is not that good though, because LiLH4 is a more blunt fellow. because the aluminum donates the H minus more willingly.
Yeah.
So when the aluminum donates the H minus more willingly, the attack will be more easier to happen on the location which has the highest delta
Higher
plus,
delta
only
plus.
this location.
Correct. Yeah.
So this will do a 1-2 addition. Whereas if I did the
1-4.
same reaction with NaBH4, that bugger will do a 1-2. That bugger will do a 1-2-3-4, a 1-4 addition first. Then follow it up with a 1-2 addition. For instance, with LiLX4 here, I'll be getting product in this case as something like this. And I'll be having only one equivalent consumed here. Okay. Whereas with NaBH4 on the other hand, if I use one equivalent, I'll be getting product obtained as this guy.
Correct. Yeah.
Okay. Then with one more equivalent, then I'll be getting product obtained as this guy.
This is because one second.
NaBH4 can do 1-4 addition also and 1-2 addition also.
But then why does it do the 1-2 first?
Now, let's say I'm taking this guy. NaBH4 here is not going to produce H minus. It actually attacks as BH4 minus.
Oh.
All right. So it is going to be going and attacking as a BH4 entity where it will come attack over here. This will shift here. This will shift here. When the attack is happening, this is a nucleophile, correct? BH4 minus is attacking.
Yeah.
So nucleophile is attacking. So we will end up having this particular cloud of electrons shifting over here. This cloud of electrons shifts over here. So I'll be getting product obtained now as BH3 is kicked out, of course. So I'll be having carbon, carbon, a hydrogen here, a carbon here, double bond here, a carbon here, and an O minus here.
Yeah.
Okay, this will then end up normally neutralizing itself. H3O plus डालेंगे अभी. This is the product stopped. Now when I put H3O plus, what will I be getting?
OH.
I'll get this.
Yeah.
Which is an enol,
Then
which will
keep it.
automerize to give me the ketone.
Yeah. Yes.
Okay. This is my 1-4 addition product now.
Yeah.
See, 1-2 addition product now. You understand the 1-2 addition now?
Yes, sir.
So basically, originally it was 1-4. That is, originally it happens like over here and over here. But then the enol tautomerizes to basically become the ketone.
Okay. Okay. Yeah.
You understand the idea? So originally it was here and here. So here and here. So let's call this as hydrogen 1. This is going to be 1. What happens here? This is going to be number 2 from here.
Yeah.
That second hydrogen now plops at this location.
Yeah.
You understand the idea here?
Yes, sir. Yeah.
Okay.
Automarizes. Yeah.
So this is going to be your 1-2 addition product over here. Now that doesn't mean this guy cannot do 1-4 addition. So it will do 1-4 addition, 1-2 addition again in the next step. Excepting it will do it over here now. 1 and 2 here. Normally. Things are clear here now?
Yes, sir. Yeah. Okay. Sir, why doesn't NaBH4 reduce like carboxylic acid and ester and amide?
Repeat, sorry.
Why doesn't NaBH4 reduce carboxylic acid and ester?
Carboxylic acid is not going to be reduced even by LiLH4, no?
Okay, yeah, that's true. So this will also undergo acid-base reaction.
Yes, of course. Of course, of course. NaBH4 is also a base. It can definitely undergo acid-base reaction. Why not?
Okay, what about the ester then? Why doesn't it get reduced?
See, when you're going to be having the ester in this particular case here, the ester does not need just a nucleophile to act as a nucleophile over there. Why?
Oh, addition and elimination. Yeah.
Yes. Addition and elimination also has to happen there.
Okay.
So you have to have that species which is attacking also
Being able to
capable
stabilize
of
the leaving.
staying while the other guy leaves.
Sir, can you repeat what?
Think
I'm
here.
missing.
In the Esther case over here, let's go back to it and see what happened. In the Esther case here, what has happened over here? You had one guy attacking as nucleophile, which was this bugger here.
Yeah.
And another guy left.
Yeah.
Correct? Huh?
Yeah.
So the guy who is attacking should be better at staying.
Okay.
That means it should be a very good nucleophile, a strong fellow.
Then the leaving group.
Only then it will stay.
Yeah.
In the case of NABH4 there, what is my nucleophile there which is attacking? Is it H minus?
BH1 minus.
Yes. That is the problem.
So that's a weaker nucleophile then?
Yes, it
RO
is.
minus. RO minus.
No, it's a weaker nucleophile than H minus.
No, sir, you're saying that.
Stop. Here, what is the nucleophile which did the job?
H minus.
That is the guy which kicked this guy out.
Yeah. Oh, so it's weaker than that. That's why you cannot do that.
Yes, so BH4 minus cannot kick this bugger out.
Oh, okay.
Why?
Correct for me.
Because H minus is much less stable.
Much less stable.
Think
Correct.
about the difference in stability between H minus and this guy.
Yes,
A large difference in stability.
Yeah.
So the H minus being highly unstable, happily and very comfortably kicks out this fellow, which is acceptable.
Okay.
BH4 minus is also acceptable. Not too shabby.
Yeah.
So that guy cannot kick this guy out that easily.
Okay.
You understand the
Okay.
idea?
Yes, sir. Yeah, I got it. Okay. Sir, one minute. So in the case of reaction with primary amines with NaNO2 and HCl,
We're still not done discussing acid derivative group.
oh, okay.
There is one more acid derivative. Which one?
Amine.
Correct. So if I take this guy and I hit it with LiLH4, what do you think I should be getting?
CH2 and H2. CH2 and H2.
Give you a gut answer. Correct. Good.
Yeah.
Good. OH के बदले में you'll be getting NH. How many equivalents?
1.
Think. What is happening?
The first
We should have RCH2 बनना है from C double bond. Correct?
Yeah.
H minus here twice. And H plus here twice. Correct? The H plus will be from what? From H3O plus.
So, yeah.
Okay. Yeah. Whereas the H minus on the other hand will be from what?
This is LiLH4. Sir, can you write the mechanism just once? Can you write the mechanism once?
In this particular one here?
Yes, sir. For this one.
No. Because it's going to be a lot more complex mechanism than what you're assuming. Or maybe you're assuming the correct mechanism only. So it's going to be something like this. I'll give you the steps so you think about it for yourself. It's not that complicated once I give you the steps, what should be the method. So you'll first be getting something like this.
OH plus.
Correct.
Huh.
Now you will have elimination of a water molecule.
Oh, like that.
Hmm.
Oh, like
Yes, yes, yes. It'll get weird.
okay. Why can't we just add another H plus and then that leaves us H2?
Yes.
Why can't we react with H3O plus? Then we get an OH2 plus, right? And then we get a carbocation.
Stop. This system is similar to geminal diol, which
Okay.
is going to be something which is like this.
Yeah. COH.
What's
Yeah.
the problem which happened there? The lone pairs of oxygens on each of those oxygens end up repelling. Here, the
Rebelling.
same kind of shit is happening. Nitrogen is there, na?
Correct.
It
Yes.
also has a lone pair, right?
Yeah.
The same kind of crap happens here. And it
Oh,
eliminates. So it will be basically an intramolecular acid-base reaction and then eliminated.
that's
That's why I said it is
interesting.
not a straightforward mechanism. Even if I give you what is going to be happening, it will still be a little bit complicated. And more importantly, how the hell does it matter what is the internal steps?
I was just wondering.
Stop. You're not thinking correctly here. You're getting sucked into the unnecessary trap of mechanism. For instance, if I'm asking you to, what to say, clean your nose, do I give a shit whether you do it with your thumb or your little finger or your ring finger or a earbud? No, I don't really give a crap.
Yeah.
Yeah, I got distracted because I heard some noise in the house. Sorry. What was I discussing?
This mechanism. You're telling it doesn't matter.
Yeah, so the mechanism is not exactly obvious even when you know the steps over there. And
Yes.
the point here is you don't need to know mechanism. Because how the hell am I supposed to know is this the exact steps which are happening?
Yes.
Think of it like this. How do you see a mechanism? How do we know a particular mechanism is happening? Can you guess?
The same with which products. Which
So
species that's present.
if I'm going to be seeing, say, a reaction, in this case here, you cleaning your nose.
Mhm.
Okay, I've asked you to clean your nose, you're going to clean your nose. Let's say there is thousands of you, and every one of those thousands of you is now going to be cleaning their noses individually.
Mm.
Each of them will follow a different methodology. Some of them might be eating with one hand and then cleaning their nose with the other. But if I'm taking just a photograph each time,
Mm.
I'm going to take just a photograph each time in the sense I'm going to be just pointing a camera at you, any version of you, randomly in that time period when you're going to be, when I've told you to clean your nose.
Mm.
And I'm taking photographs randomly. At one instance, I see like a photo like this, where there is like a food particle which is coming close to your mouth, but it is also close to your nose.
Mm. Yeah.
So, should I assume that you are cleaning your nose with your food as a
No.
possibility?
No.
It looks like a possibility like that, nah?
It does. Yeah.
You understand what I'm trying to tell
Yeah.
you? That is the fallacy of mechanisms. We assume too many things when we start looking at mechanism as steps which are being followed for sure. We don't know what are the steps, sincerely.
Mm.
We make up the steps in between. What do we know? We know what is present in between. Because literally exactly what I described is what we do. We see a change which is happening, we take snapshots of it at different time periods. When you know the reaction is happening. And then we decide, okay, these are the photo images which I'm seeing here. I see the dude having nose near hand. I mean, hand near nose. I see dude having, in one case, some tissues there near nose. In one case, it is going to be like some other finger is near nose. Different finger is used. And in one case, I am seeing food also coming near. But the food is not being seen that often. I'm also seeing other photos where the fellow is having food in the mouth.
Yeah.
There's no food also near the nose. What do I decide then? You understand the dilemma there, right?
Yes, sir. Yeah.
So it is always better not to trust the steps. Trust the intermediates which are found, not the steps.
Okay.
You understand the idea there? How the steps happen internally, that is me and you basically debating over what is the exact. Did the fellow eat the food first and then clean the nose, or did the fellow what to say clean his nose with a dirty hand? Yeah, there will be some cases where the dirty hand is being used anyway.
Yeah.
So for the sake of an argument, if you end up getting into what step happened first, you'll get sucked into shit, which is not worth it. So don't bother about mechanism too much. Bother about what are the intermediates formed. What are the steps involved during the process? Not exactly about
Exactly what's in
which is going to be the exact step which is going to be coming first.
Okay.
Understand if it's reversible. Understand if it's in equilibrium. Those things are important. Those are data points which will give you more understanding about what should be the mechanism. Because if you see that the entire reaction is reversible, what does that mean? That means every goddamn step in the way is some kind of funny reversible step there.
Yeah. Yes, sir.
We know there are mainly two reversible reactions involved in organic. What are they? Nucleophilic addition, elimination, acid base.
Yeah.
So these two are going to be liberally used.
Okay.
You understand the idea here as to how to
Yes,
predict that. So mechanisms will be bit more flexible. Don't make yourself too rigid.
Okay.
Okay, next up. Your product guessing was good. I really like that. This is a good guess. I've seen lots of people mess up on this guess here. Good guess. Next up. Dude, there's a good chance that I will close the class in like 10-15 minutes.
Okay. Yes, sir. From primary amines, if we reacted with NaNO2 and HCl, we get alcohol, right?
Yeah, that's a good reaction. We'll discuss that.
Okay.
You discussed that reaction already?
No, sir, we didn't.
That's an important reaction. We'll talk about that now. So, first of all, let's say I'm going to be having RCH2NH2. Okay. Now I want to convert this into an alcohol. Okay, so direct corresponding alcohol, let us say. Now, one of the simplest ways is by a process. I'm assuming you did nitrous acid type of HNO2.
Yes, sir.
NaNO2HCl.
NaNO2HCl, yes.
Okay, all right. So now let's talk about what is going to be done over here in this process here. In this process, when you are doing this conversion here, we are going to be looking at one very critical reaction. Very important reaction of amines over here, which is called as diazotization. So the name of the reaction is diazotization. Again, shitty technical name. Nobody needs to give a shit about the name. Okay. Now let's look at what is really happening here. You're going to be having a reaction of this guy with NaNO2 plus HCl. Correct?
Yeah.
Let's look at what is NaNO2 plus HCl really. NaNO2 is a salt of HNO2 and NaOH.
Yeah.
Right. So the HNO2 here is a much weaker acid compared to HCl. All right. So when you're going to be having HNO2, this is a weaker acid. than HCl. Okay, so if it is a weaker acid than HCl, what will be happening now is a regular displacement reaction. Okay, so when you're going to be having a standard displacement reaction happening now, what will happen is very straightforward. NaNO2 and HCl will react to give you NaCl and HNO2. This HNO2 is not going to be staying simply as it is. This will react with extra HCl to give me H2NO2 plus 1 plus Cl minus.
Yeah.
Okay, so now let's study the structure of this H2NO2 plus 1. HNO2, by the way, has a structure like this. HNO2, that's all, blunt.
Yes, sir.
If this fellow is going to be accepting a H plus, where will the H plus get accepted? It will get accepted here.
Yeah, yes.
Okay, so this will effectively end up becoming N double bond O. There will be a lone pair over here, of course, and we'll have an OH2 plus 1. This is the structure for H2NO2 plus 1. Okay.
Yeah.
So this H2NO2 plus 1, next step is going to be doing the obvious thing.
Yeah.
Basically, you'll end up having these two electrons being taken over by this oxygen, and this entire thing will get the hell out.
Yes, yeah.
Basically forming NO plus 1 plus
NO
H2.
plus.
So we'll have H2NO2 plus will effectively break down to give you NO plus plus H2. This NO plus is called nitrosonium ion. And this is going to be your reactive species now, which is going to be going and doing the reaction.
Okay.
The reaction is actually even more complicated from here. It gets more funnier from here. So I'm not going to be doing the exact steps now again and again, because the steps are not going to be really important. What you need to understand is what is happening from those steps.
Okay.
So in this particular case here, what has happened so far is this. We are going to be having NO plus generated as of now. And the compound we have is an amine. Okay.
Yeah.
So now we are going to be having this NO plus is going to be reacting as an electrophile with the amine, which is the nucleophile. So you can think of it as an acid-base nucleophilic addition elimination. However you want to do it, no problem. Ultimately, what is going to be happening is very simply put, we will be having an elimination of this.
Okay.
Forget about how the mechanism is going to be. This is not going to be a one-step reaction. It will happen in a bunch of steps sequentially. And we will have this H2O getting eliminated out. If the H2O is going to be eliminated out, the guys who are left over are basically going to be this nitrogen. Let me mark
nitrogen.
Blue now. This nitrogen, and of course the plus 1 also. Because H2O will not leave in any other form. It will leave as H2O only. So what happens over here is you will be having the product obtained now being something like this. Have a look at the structure.
Okay.
This is the structure with a plus 1 on this nitrogen here.
Okay. Yeah.
So this is called as your diazo compound. Now, this is going to be produced along with whatever was the partner for NO plus. What was the partner for NO plus?
H, H2.
No. The partner for NO plus was Cl minus. H2O was the other partner, but H2O was the medium. So what is the real ionic partner for NO plus? The Cl minus.
Okay.
Because the H2NO2 plus is what became NO plus and H2O, correct?
Yeah. Yes, sir.
What was the partner for the H2NO2 plus? That was Cl minus.
Yes, sir.
That same guy only became NO plus and H2O. So H2O doesn't require a partner. So the NO plus's partner is now the Cl minus. So in this case, again, the NO plus has now broken off and become a H2O. So who is left over as a partner for this fellow here?
Cl.
Cl minus. So in this particular case here, this species is called as diazonium ion. The actual name is diazonium ion. So you can call it as alkane diazonium ion. And this entire compound here is called as alkane diazonium chloride.
Okay.
Okay. Now, this alkane diazonium chloride is going to be the next fellow who is going to be reacting now in the next chapter. So we're going to be having our CH2 N2 plus Cl minus. Now this is going to be reacting with water. Or you can also do H3O plus. And simple warming will basically get the job done easily. Now, what is going to be happening in this process here when you do this? You will simply have water molecule becoming the nucleophile, which will come and attack here and kick out the nitrogen as a gas molecule. So why is this reaction going to be happening very easily in the forward direction? What is going to be the product here? You will get RCH2OH plus you will get N2 gas being kicked out.
Okay.
So this reaction will be something where warming. Why is this helpful here? Because for the overall reaction, let's call this as some random reaction X over here. Or rather, let's call it as reaction 1. So for reaction 1, for reaction number 1, delta S of reaction 1 is positive. Why? As gas escapes.
Gas escapes, yes. Delta Ng.
Okay. This means we will have delta G, which is delta H minus T delta S. Let's say delta G of reaction 1 if I'm considering.
Yeah.
It's favored, which means becomes more negative at higher temperature. Why? Because delta S is positive.
Yeah.
You understand the idea here? This fellow delta G will become more negative at higher temperature here. So that is why we warm it.
Okay.
Clear so far?
Yes, sir.
Now, in this process here, one thing to watch out for here. This particular step here, where you're going to be having this reaction happening, this reaction may go via carbocation formation.
Okay.
In rare cases, usually no carbocation formation, but it may go via carbocation formation in some rare cases in some specific mediums. If it goes via carbocation formation, what can it do?
Rearrange.
Correct. That's all.
Yes, sir. I think my doubt is regarding that. Like we were given a few reactions, and then the major one was the alcohol, but then along with that, elimination products were also there.
Think why? Carbocation. When you get carbocation, it can do rearrangement. But if you do carbocation and rearrangement, you can also do elimination there. Carbocation, you remember, once you get carbocation, it can do SN type or it can go elimination also.
Elimination type, yes. You want to yes and no. First step is same for them. So,
You
so like
understand the point here?
it's not like from the alcohol again, it's turning into this. It's like
Not necessarily. It is not going to be going to the alcohol stage. It will get elimination from the carbocation itself.
from the amine itself.
Not from amine. After the diazonium, after this stage. This process here. This step here, which we are talking about here, this is the guy which can go via C plus formation.
Okay.
If it forms the C plus, it can do anything else. All the branches which it can open up to from carbocation, they open up.
Okay.
You understand what I mean from there?
Yes, sir.
You can
Yeah.
get a rearranged alcohol. You can get an alkene. All of those start depending on what conditions you're putting it under. Because you've now got a carbocation.
Yes, sir. Yeah.
We'll be going back to our Sunday schedule from coming week onwards, dude. This week Sunday was a little tight for me. So morning we'll have sessions.
Okay, sir. Yeah.
Okay.
Yeah.
Now, where are we other than next reaction which you have problems in so far? Or any other reactions which you have some doubts on?
Sir, for hydrolysis of ester.
Estera, ethera.
Ester.
Estera, ethera
Yeah.
again.
Ester.
Confirm?
Yes, sir. Like we were given an isotopic oxygen, and then sir, like, could you write a ester with an isotopic oxygen, like marked oxygen? Yeah. Plus H2 will give a carboxylic acid and an alcohol, right? Yeah. Yeah, that's it. Here, where will which oxygen will go where? I mean,
No. So this is another very famous reversible reaction.
okay. So this is reversible because it's
Stop. Don't ask questions now. Stop. Pay attention for a bit. Now, this is a reversible reaction here. Now, why did I point out that this is reversible here? Mainly because the real mechanism to understand which oxygen is going to be placed where doesn't come from this direction. It actually comes from this direction. All right. So what is the actual reaction which you need to understand here? This is called as esterification reaction. All right. You have not done the reaction mechanism yet.
Okay.
Give you the answer for this. But you've not done the esterification reaction mechanism. Now, esterification, when you're going to be considering that reaction mechanism, how is that going to be working out? So the product formed is going to be RC double bond OR dash plus H2O. Now let us mark each of these here. So let's call this oxygen number 1. Let's call this oxygen 2. Let's call this oxygen 3. Okay. What is
Yeah.
going to be happening is, depending on the R group and the R dash, you will have different possible mechanisms being applicable, truly, in the esterification itself. But the most common mechanism slash standard mech, for that, what will be happening is, you'll have this as 3. This can be 1 or this can be 2.
Okay.
This will be 2 or this will be 1.
Hmm.
You understand the idea now?
Yes, sir.
So the exact same will happen in reverse.
Okay. Hmm.
This is for the most common standard mechanism. So this is what you memorize. Now there are going to be weirder cases where you have some funny mechanisms being possible, but those are case specific type of scenarios, what you call as exceptions. But they are case specific. Think of it like that. All right. This is going to be the default setting.
Yeah. Okay.
You understand the idea here? So in reverse,
sir.
how do you proceed over here? Whatever is present here at this location here or this location,
Yeah.
will be here, these two. It can be either. In the sense here, this can be either 2 or 3. Similarly, this will be either 3 or 2. If this guy is 2, this will be 3. If this is 3, this will be 2. And this will absolutely be 1.
Okay.
Default setting. So think of it as default. If you are going to be having some more funny things happening there with more, if the R and R dash are exceptional fellows, default will not be followed.
Okay.
Some special shit will happen.
Okay. Yeah.
Fair enough. You understand the idea here?
Yes, sir. Yeah.
Now you'll be learning more about this when you are dealing with esterification mechanism.
Okay. That'll come in this chapter only.
Yeah, this obviously this chapter, it's a reaction of alcohols.
Okay.
Huh.
Okay.
Okay.
Yeah.
Next up.
For now, that's it. Yeah.
For now, you are closed.
Yeah. I mean, I'll go through them again to see if I have
Yeah,
anything.
please. I think I'll also close the session here today, then more or less.
Okay, sir.
Because I'll just confirm, give me a minute if I have more time or not. If I
Okay,
have
sir.
more time, yeah, we can continue. But yeah, there's a good chance I'll also have to close.
Yes, sir. That's it. Nothing else.
That's about it, is it? How about
Yeah.
NP reduction? You understood that properly?
Oh, this thing. I mean, they didn't. It's like he didn't give many points based on this. He just gave the reaction. And that's it.
So you just got the reaction. In NPV reduction also, there is going to be a couple of points like this where you need to track what is going to be going where. So let's quickly discuss the what I say, not mechanism, whatever we have been given for NPV. So what is the name which has been given for it?
The reagent.
They give you the full name for this shit?
Yeah.
Yeah, okay. Let's just not bother with it.
Pond.
Yeah, the Pondorf, Verli, whatever nonsense.
Verli.
Okay. So let's directly go for the reaction here. So you're going to be having, give me the reaction you have learned now.
So, ketone or aldehyde plus this isopropyl alcohol gives plus this aluminum isopropoxide equilibriums to this.
Equilibriums to what?
Yeah.
Okay.
RCH, like secondary alcohol. RCH, ROH plus this CH3 C double bond OCH. Yeah, that.
right?
Yes, sir. That's it. Yeah.
Okay. Now, what is the reagent which you have used in the process here?
Aluminum isopropoxide in isopropyl alcohol. AlOCH3 twice one twice.
Now, isopropoxide is going to look like this.
Hmm. Oh, minus.
Oh, thrice.
Okay. Yeah.
Aluminum will be 3 plus, but technically let's not call it 3 plus. Let's just put it like this.
Yes,
Now,
sir. Yeah.
let's track every bit of hydrogen which is present here. So in this case here, these two are the same, by the way.
Yeah. Yes, sir. Why did you write it twice?
The isopropyl alcohol.
I mean, like, why did you write it twice?
Because here it is a medium along with that species over there. So just by mistake
Oh,
put it twice. I did not notice it properly that way.
okay.
So
Okay.
now in this particular case here, let me just rub off this guy then. Nahi chahiye. So I'll
Hmm.
rub this fellow off then. Let me capture this also and then put it to this side.
Hmm.
Okay. So you're going to be having in this particular case here, this reaction here involves each of these species over here. So let's tag them first. So let's call this hydrogen 1. Let's call this hydrogen 2. Let's call this guy hydrogen 3. Okay. So now, which fellow is going to be going where? Is the real question which we need to start looking for answers in this particular case too. So first of all, we are going to be having hydrogen number 3 being present here.
Huh. Yeah. Okay.
Okay. And hydrogen number 2 is going to be present over here.
Okay.
Are you clear with what's happening?
Yes. Sir. I mean, yeah. Hmm.
Hmm?
Yeah.
Now, what happens in the interim though is this within the reaction mechanism is these two will react as and when this particular part gets consumed. When
Hmm.
more and more of this gets consumed, this will go and provide to become this.
Okay. Yeah.
So technically, 3 and 1 become interchangeable eventually. When they interchange, then this can become 1.
Hmm.
You understand the idea here? First, this fellow will be only 3.
Yeah.
When this aluminum isopropoxide gets consumed, more and more of the isopropyl alcohol will react with the aluminum to give more isopropoxide.
Yeah.
As that becomes isopropoxide, this 3 will, the 1 will become 3 there, obviously.
Yeah. Yes.
Why? Because this fellow, which is
Like
present here,
supplying.
it is losing the hydrogen here, na?
Yes, sir.
Every time it loses the hydrogen, it will become this.
Okay. The
And
aluminum.
when
Okay.
it becomes this 1 would have become 3.
Okay. Understood. Understood. Yeah.
You understand the idea over here?
Yes, sir. Yeah.
So this is basically what is going to be happening over here. And
Hmm.
you can think of this as concerted mechanism. Six-membered ring transition state.
Oh.
and something like a redox. Not exactly a redox, but yeah, consider this is enough. Actually, this is more than sufficient. This should be enough information to basically proceed here. So what is going to be the reacting fellow there? It is going to be a two-step reaction where first step you'll have this fellow and this fellow reacting. Second step the product formed will react with this guy. Don't bother.
Okay.
When you discuss this more, you'll learn. And for the time being, this is sufficient.
Okay.
You understood what's happened over here? Do you want to
Yes.
discuss the mechanism?
Will we do it again?
Not right now. When the
No.
next one is also discussed, if your teacher discusses the next one also,
Next one
let
is
me know then. I'll discuss the mechanism. The other one is called as open or oxidation.
He mentioned this. He said the reverse reaction is called open or oxidation.
So if he discusses open or oxidation, then we will discuss mechanism. It will help you understand things a little bit better.
Okay.
That is going to be basically reverse in a sense.
Back.
So back is not doing it justice. Calling it back is not justifiable. So in this here, what happened over here? We had a general aldehyde or ketone reacting with a specific alcohol.
Yeah.
To give me a general alcohol and a specific aldehyde or ketone. So in the open or oxidation, I will be taking a general alcohol and a specific aldehyde and ketone. So when I say general alcohol, I'll be taking, say, something like R, CH, H/R dash, OH. Okay, I'll be taking a random general alcohol over here now. Something which can undergo oxidation. Okay, something like this. This I will now react with acetone.
Okay.
This time though, I will be using aluminum tertiary butoxide. So what is the problem with aluminum tertiary butoxide now? There is no hydrogen here. That is this location here. There is no hydrogen there, correct? So what will happen is this fellow, that is this aluminum fellow, will react with this guy.
Yeah.
To first produce that species. And then that will react with this and give you the reaction. So let me give you the mechanism. Let me give you the product here. If you end up discussing this reaction again in your school, then we will talk about the mechanism a little bit more. So what happens over here is we will be having this hydrogen. Let's call this hydrogen number 1. This will become this hydrogen here. And this hydrogen number 2 will become this hydrogen. Clinically.
Okay.
You understand the idea here? So it will be like clinically transferred out beautifully in terms of the mechanism over here. How? We will have first reaction will be this fellow with this fellow.
Okay.
Then the product form will react with this to give you this.
Okay. Yeah.
So in this reaction here, you can tailor oxidize whichever what is a target location, target alcohol you wish to oxidize. This is what is going to be your open or oxidation. It's depending on how much importance your system seems to be giving it. We will
Hmm.
talk more about it later. We will
Okay.
close the session here. I will see you on mostly Sunday,
So,
maybe Saturday. What is your status otherwise?
so Saturday I was school.
I know,
Yeah. I have another class on Saturday. I'm not too sure, sir. I mean, as
not
well.
sure about Saturday.
Yeah.
All right, okay, all right. So I'll see you mostly on Sunday then,
Yeah.
morning then as usual.
Sir, like after preparation methods, what else will come? Like reactions and
Yes.
react.
Hmm.
Okay. So can I do questions of this chapter like
Please do.
with the
You
present,
should
like
start.
with just this?
What does with just this mean?
I mean
You
preparation
understand that
method.
organic is always cumulative now.
Yes, but like
So
I mean like
yeah,
okay.
so you have that. See, as you progressed in organic to a good extent now, we will end up having more of these cumulative parts anyway coming in. So when
Hmm.
more of these cumulative parts are coming in,
Previous methods.
we will basically end up having, or you will have more room to try out questions.
Hmm.
So you are going to be having more room to try out questions certainly now. So yeah, you
Okay.
can certainly start.
Yeah.
In fact, I recommend that you start. At
Okay.
least you start with revision of alkyl halides and Grignard at least to an extent. Grignard may
Okay.
have enough alcohol parts coming in. So
Hmm.
वहाँ से you should definitely start.
Okay. Hmm.
Okay. Anything else, dude?
Hmm. Sir,
Hmm.
the reshuffling test result I asked my teacher.
What happened? How bad?
Uh, it was, I mean, relatively, I think it was okay, but could have been like mains. I got 194. There was rank was like around like they didn't tell the exact rank for mains, but it was somewhere between 8 and 18, something like that.
What?
Yeah.
In the entire group.
Yes, sir.
So your friends are a bunch of liars.
No, what? I mean, they got what they expected. I think.
Okay, we will close off. We'll have this conversation later. All
Oh,
right. Bye bye. I am
thank.
interested in the results though.
I don't know the sheet. They just told like orally, so because.
We'll talk on Sunday. I actually have to go now. Bye bye.
Oh, thanks.
Have a good
Thank
night.
you. Good night, sir.
Yeah.